We are looking at R.D. Sharma Solution Class 12 Chapter 19 Exercises 19.6 Indefinite Integrals we are taking. So in this exercise, most of the questions, I should say all of the questions are based on trigonometry. So we are actually integrating trigonometric expressions, and see, trigonometry is so important in all the chapters we have seen. Differentiation, integration, trigonometry will always be there. So this sin square 2x plus 5, you know that sin square theta is 1 minus cos 2 theta by 2. Cos square term or cos square question will also come. Sin square x by 2, cos square x by 2, all is going to come. So just remember this formula. Sin square theta is 1 minus cos 2 theta by 2. So when we integrate this, we will replace the sin square 2x plus 5 by this formula, which is 1 minus cos 2 theta by 2. So this is 2x plus 5, and since it is 2 theta, we have to multiply it by twice. So it's 4x plus 10. I am replacing sin square 2x plus 5 by 1 minus cos 4x plus 10 by 2 dx. So separate them out, and it's always advisable that take the constant outside of the integration so that it doesn't create problem while we are doing the other computations. So integration of dx, and the other part will be integration of cos 4x plus 10, because 2 already being taken outside. This is your dx. See how easy it has become. This is half. Integration of dx is x. Cos is sine 4x plus 10. Now one more thing has to be done. Whenever you have two expressions, see, cos of an angle, but the angle is again an expression. So that expression has to be differentiated, and that differentiation value has to be divided. Okay, that means cos is sine, which we have done. But 4x plus 10, it has to be differentiated, and that has to be kept in the denominator. That's why I am putting this 4 in the denominator. And of course, it has to be ended by a constant of integration, which don't forget that. So if you want to more make it pleasant to look, just multiply half inside, x by 2 minus sine 4x plus 10 by 2, and 4 into 2 is 8, so plus c. So this is so easy. If you know the formula, this question is just a piece of cake for you. So these were just 4 steps which I was talking about. Only the formula is the key, otherwise things are very easier for you then. Now we are leveling it up. And in the next question coming up, one more level up will go. So this is sine, previously it was sine square. This time it is sine cube. And for that we know the formula of a sine 3 theta. Sine 3 theta is 3 sine theta minus 4 sine cube theta. So this, there is no excuse. You have to remember this formula. So this sine cube theta can be written in terms of the other terms. How do we write it? Sine cube theta will become, just take 4 sine cube theta on one side and the others on other side and divide it by 4. That is how you can do it. If you remember it, you can just write it directly. Sine cube theta is equal to 1 by 4, 3 sine theta minus sine 3 theta. Let us now integrate it. First is, whatever is outside, keep it outside the integration. That will make your computation quite easier of inside integrals. Otherwise you will be caught up in arranging the number which is outside, or a constant which has nothing to do with the integration, because integration of if there is some value, constant is just like that. So 1 by 4 I have taken common. 3 sine theta minus sine 3 theta. Theta is 2x plus 1. So 3 sine 2x plus 1 minus sine 3 into 2x plus 1. So 6x plus 3. This is sine 6x plus 3. Alright. So this sine 3 theta. Sine 3 theta has another formula. 3 sine theta minus 4 sine cube theta. But here, because 3 theta is simply 6x plus 3, we can easily regard it as just a sine theta. So 1 by 4 is already there. I'll use it later. Or you can just multiply this, take this 3 in the front, it will be 3 by 4. Sine 2x plus 1 integration, 1 term will be this, and 1 by 4 multiply. This is sine 6x plus 3. And see, they all followed by dx. I'm not writing it, but it is there. Sine theta integration is negative cos theta. And then differentiation of 2x plus 1. Differentiation of 2x plus 1. Whatever is the result has to be has to be put in the denominator. So this is 2 in the denominator, 3 by 4 was already there. Now coming to the second term, 1 by 4, sine 6 plus 6x plus 3. So it will be minus cos 6x plus 3, minus minus plus. So we have cos 6x plus 3. And this cos 6x plus 3, differentiation of 6x plus 3 is what? It's 6. So that has to be kept in the denominator. So now this whole has become, and now the only thing is the presentation. Once your food is made, this food is made, this result is made. Next thing is to put some say spices or some fiber, say cucumbers and tomatoes on it. This is the only thing. So what we are doing here is we are just trying to rearrange things so that it looks better. So minus 3 cos 2x plus 1 divided by 8 plus 1 by 24. And this is cos 6x plus 3 and of course the constant of integration. So this formula, if you know, the question becomes very easy. So this is the another level up, is cos raised 4 2x. So this cos raised 4 formula is very difficult to remember, but we have a trick. X raised 4 can be written as x squared to the power 2 because the power or the exponents, they get multiplied. In the same way, this cos raised 4 to x can be dealt as cos square 2x whole square. Please remember, integration and dx will always be there. If I am not writing it, don't do it for yourself. You have to write this integration and dx always, sign, symbol. So cos square 2x whole square, now this is, and we have the formula of cos square 2x. We have the formula of sin square 2x. Alright. So we'll just use the formula of cos square theta because it is theta 2x is already there. So we'll use this formula and we'll try to make it easier. Okay. What is cos square x? It's 1 plus cos 2x by 2. Just remember, whatever in the left, the theta will be twice of that on the right hand side. So this will be 1 plus cos, and what will be the angle inside? Since we are using cos square x, it has to be cos 4x. So 1 plus cos 4x and divided by 2 and whole square of that, and dx is already there. So we just do it. 1 by 4 it will be 1 by 2 whole square is 1 by 4. 1 plus cos 4x whole square is a plus b whole square. So I am doing it here, a square plus b square cos square 4x plus 2 into cos 4x. A square plus b square plus 2ab. This is what I am using right now. Okay. Now cos square 4x is again appearing. So we need to reapply the formula we have just seen. Cos square 4x is 1 plus cos 8x by 2. So now you have to replace this cos square 4x by 1 plus cos 8x by 2. This is 1 plus cos 8x by 2, and then it's followed by 2 cos 4x. So now we have certain terms. You can either rearrange them, combine the similar term and then differentiate, or you can just differentiate right now. So let me combine this. See, 1 is already there. 1 plus cos 8x can be written as 1 by 2 plus cos 8 by 8x by 2. 1 by 2 plus cos 8x by 2. Here we have 2 cos 4x. 1 plus 1 by 2 is 3 by 2. This is 3 by 2. Write it like this, 3 by 2. And this is cos 8x by 2 plus 2 cos 4x. Please remember, 1 by 4 was already there. So let us integrate this first and then we'll introduce 1 by 4 again. So we are differentiating with respect to dx. So 3 by 2 integration of just dx is x only. 3 by 2 integration of dx is x only. Plus cos 8x, 1 by 4 is already outside. So 1 by 2 we have taken outside. Cos 8x will be sin 8x. And what is 8x? Differentiation of 8x. I told you already, whatever is inside, because we are dealing with a cosine term, but inside that we have an algebraic term. So we have to differentiate it and divide it. So this 8x, the differentiation will be in the denominator. Plus cos 4x is sin 4x, twice 2 was already there. Differentiation of 4x is 4, so it is in the denominator. Okay, now multiply 1 by 4, which we have taken outside for the final bringing it in. So this is 3 by 8x plus 8 8s are 64. It's sine 8x by 64 plus we have 2 by 4 for the 16. So it's going to be 1 by 8. So sine 4x by 8 and with a constant of integration. Don't forget that ever. It's indefinite integral. This is your final answer. So this is the only thing which this question needs an explanation is the formula cos raised 4 2x is written as cos square 2x whole square, and we use the formula of cos square x 1 plus cos 2x by 2. This is sine square bx. Cos square angle we have already done. So the similar way we are going to go about it. Sine square x formula you must know. It's 1 minus cos 2x by 2. So sine square x is 1 minus cos 2x by 2. So let me write it, 1 minus cos 2x by 2 dx. And this is going to be half dx minus cos 2x by 2 integration. And this is dx. Half will come in outside. Integration of dx is simply x. There is b also. This b. I've just written it as 1 minus cos 2x. It has to be 2bx. So just I'm introducing bx. So this is half. I've taken outside. Cos integration is sine, and now this 2bx has to be differentiated, and that differentiation value has to be kept in the denominator. So this is 2b in the denominator with the constant of integration. So this is your final answer. It's x by 2 minus sine 2bx by 4b plus constant of integration. This is your final result. So this is quite straightforward for you. Next one is sine square x by 2 dx. So the next question is sine square x by 2. For the following question is cos square x by 2, which is following this sine square x by 2. So if you know this next question which is coming up will be easier for you. Sine square theta, the formula is 1 minus cos 2 theta by 2. Whatever is on the left, it will be twice on the right. So we have sine square x by 2. It will be 1 minus cos 2 into x by 2. What is 2 into x by 2? It's just x. So we are having 1 minus cos x by 2 to be integrated now. 1 minus cos x by 2. See, so easy it has become just by implementation using of a formula. Half I am taking outside, integration of dx. Half we have taken outside, cos x, integration of cos x. And of course with the dx here. So we have x by 2 minus cos x is sin x divided by 2 and with the constant of integration. So we can just move a step ahead. We can just take 1 by 2 outside and it will be x minus sin x plus c. This is your final answer. This is sin square x by 2. And the next question coming up is cos square x by 2. This is cos square x by 2. So let me just write the formula, and you are quite aware of this now. Cos square x by 2 is going to be equal to 1 plus cos, whatever is there, just multiplied by 2. X by 2 multiplied by 2 is x only. 1 plus cos x by 2. This is integration of 1 plus cos x by 2 and with a dx. So I'm taking this half outside, which I generally do. 1 dx and cos dx. 1 dx is simply x. Cos is going to be sin x. There is nothing inside, so we are not going to differentiate anything. We don't have to worry about this. Half is already there. Plus c. This is your final result. Constant of integration is always there because when we differentiate, the constant terms become 0. So when we integrate, which is the opposite of the differentiation, we have to include a constant, which we have actually eliminated when we are differentiating. So this is your result. And sin square, cos square we have done, just the formula, nothing else. Now cos square nx dx. So either it is cos square anything inside, don't worry about that. Just concentrate on cos square x formula. Cos square theta is 1 plus cos 2 theta by 2. If it is cos square nx, it will be 1 plus cos 2 nx by 2. So this 2 is already there, 1 by 2. 1 plus cos 2 nx dx. We are going to deal this half later. So integration of dx plus integration of cos 2 nx and dx here. Integration of dx is x plus cos is sine 2nx, and differentiation of 2nx is going to be 2n, and that has to be kept in the denominator. So this is in the denominator. So just write this 2n in the denominator. Half was already there, bring it in. This I'm changing it here only for the time. So this is the result. So don't worry about this nx or anything which comes up. 1 plus cos 2x by 2 is the formula for cos square x. And for sin square x, it is 1 minus cos 2x by 2. Okay, this is sin x in front and under root of 1 minus cos 2x. The first thing what we are going to see here is 1 minus 2x has a direct formula. It's 2 sin square x. 1 minus cos 2 theta is 2 sin square theta. So it has a direct formula. So 1 minus cos 2x will be replaced by 2 sin square x. Sin x is already there outside. We have 2 sin square x. Just take it inside the root. So it will be root 2 sin square x. So under root 2 here, sin square x will be sin x. Now bring it here. So sin x and under root 2 sin x will become under root 2, you can take outside. It will be sin square x. And this sin square x dx. So do we have any formula for sin square x? We again have a formula for sin square x, right? Sin square x is 1 minus cos 2x divided by 2. Whatever is on the left, the twice on the right. We will replace this sin square x, so change it by 1 minus cos 2x by 2. So let us integrate this. Integration of root 2 by 2 will deal later. It's dx minus cos 2x integration dx. So integration of dx is what? It's x. Cos 2x is sin 2x. And since I told you that whatever is inside sin or cos, you have to differentiate it and divide it. So 2 will be in the denominator. Root 2 by 2, you can write it like that, or you can just make it simpler. Root 2 by 2, multiply numerator denominator by root 2, you will get 2 by root 2, 2 gets cancelled, 1 by root 2. So finally we got 1 by root 2 x minus 2x by 2. This is your final result. Don't forget about the constant of integration. Okay. So this is your result. Okay. You can refer to it. So this is all about this exercise 9.6. Just stay tuned for 19.7. Till then, thank you so much. Take care of yourself.